Hi everybody, welcome back. This is Math-172. Today we're talking about the law of sines and cosines. So I just wanted to kind of review those before we get into an application problem. The law of sines tells you that if you have a triangle, and this is angle A, this is angle B, this is angle C. This is side A because it's across from A. This is side B since it's across from B. And this is side C. The law of sines says that the side length divided by the sine of the angle opposite it. This length divided by the sine of angle A is equal to the length of B divided by the sine of angle B is equal to length C divided by the sine of angle C. So this is useful usually when you're given two sides, or, well, it just depends on the problem. We're going to get into this as we move forward. But the law of cosines is a little different. Using the same diagram, it tells us that the length of side A squared is B squared plus C squared minus 2BC cosine A. We have three lengths, A, B, and C, and only one angle. So if instead you don't have angle A, but you have angle B, then this becomes B squared is A squared plus C squared minus 2AC cosine B. And these should be capitals. Okay, and then if you don't have angle A or angle B, but you have angle C, so then C squared equals A squared plus B squared minus 2AB cosine C. So note that the one on the left of the equal sign is the side that corresponds to the angle that you're using. And these are the other two sides, squared, minus 2 times the product of those sides. Okay, so that's just a review of the law of sines and the law of cosines. And so now we're going to get into some problems from the practice book. So the first problem we're going to be doing is this one. Bob walks along a straight road. He decides to leave the road and walk on a path that makes an angle of 30 degrees with the road. After walking for 100 meters, he turns through an angle of 75 degrees and heads back toward the road. Two questions. First, how far does Bob need to walk? So how long is this side? And then second, how far down the road is he? So how long is this side? Okay, so we're going to solve problem 1. So, problem 1, we have, this is 100 meters, and this angle is 30 degrees. We know that this angle is 75, which means this one is 105. And then we have two questions. All right, so we know that the sum of the internal angles of a triangle, 105 plus 30 gives us 135. And so altogether it has to be 180 is 105 plus 35 plus this angle theta. So 180 then is 135 plus theta. So we subtract 135 from both sides. 45 degrees is our angle theta. So that's 45 degrees. Okay, good. So now we have three angles and one side, and we want to solve for the other two sides. So I'm going to choose this angle and this side to solve first. So we say we're going to use the law of sines because we have angles. So we've got 100 over sine, which one? The one that's across from it, over the sine of 45 equals, I guess we're just going to call this b, right? B over the sine of 30. Okay, so again, it's the side length divided by the sine of the angle opposite is equal to the ratio of this side length divided by the sine of this angle. Okay, so to get b alone, then we've got 100 times the sine of 30 over the sine of 45. So this is 50 over root 2 over 2, right? So this gives us side B is 70.7 meters. All right, great. So then the second question they ask is, how far down the road are you? So that's a question about this side. And we're going to go with the ones that we were given, right? So we know that 100 over the sine of 45 is equal to this guy, we can call him C, over the sine of 105. So then C is 100 sine 105 divided by the sine of 45. And when you substitute in those numbers, you get 136.6 meters. Okay? So guys, this is problem 1. It uses the law of sines. You're given, well, and you can figure out 3 angles and asked to find 2 sides. We're going to be moving on shortly.